Hi. While I'm in Berlin preparing for the conference, which is in 1 month, I did a little test program which plays around with Penrose tilings today. I just want to quickly record an episode about that, though this doesn't get lost in you. See a little bit of code which I ported today from Python. My experience with that was that it was fairly easy to port the math, but some of the code which was related to the complex numbers which the code uses was not that easy to use, because I'm not used to Python and I'm not used to seeing like numbers with a J on them, and so I wasn't really sure what does it represent and how to port that to C++, but more on that later. Now if I guess just go into the browser here, this is the posting from Pressing on Programming 2011, actually posted, so it's quite old, which kind of describes how to do a Penrose tiling in a program, and it uses Python. But I don't speak Python, so I ported all this Python code here into C++, and that's basically what I'm talking today about. And first we see this tiling sequence here, which I just quickly want to show you in the code, because this was also a little bug which I had, which also gave kind of awesome results. But so this is the code which divides a triangle, and as you see here, when you make this a minus b and not b minus a, then you get the errors, which I will show you later in pictures. So this is just a code which takes a triangle and returns a new, actually first I had it returning a vector, but actually this is a vector which constantly grows with new triangles. So I wanted to make a function which adds to a vector, because otherwise I would have been creating a new vector and then adding the new vector to another vector, and that way we just grow in the correct vector directly. And this is just straightforward ported from the Python code which we saw previously. And also saw somebody posted a different version for tilings in the comments, and I plan to kind of probably also have that in here and kind of, I don't know, maybe randomize the tiling through that or something. I want to play with patterns and see what the result is and what looks good later. So, and we see this is a canvas, this is a QWidget derived class in Qt. I draw all this in Qt, and this is all in C++. This is a function which creates the actual stud triangles, as we see when you see in the program. And this is like a circle with 10 directly spaced triangles, and this rect function is something which gave me a little bit of a problem. If I go back into the browser, we can see why, because this is exactly where I had a problem. This is example program, by the way. That's how it looks. And if we go back to the browser, I can show you the code which is responsible for starting this. And here we see the call to C rect, and this is a call which isn't really in the kind of the C++ world available. This is a math library from Python, and for complex numbers, I guess C math. And yeah, this is where I kind of was, well, what is rect and how can I replace it in C++? So I looked up rect, and if we go down to rect here in this page, we kind of see this is just this. This is totally easy until you see that here you take it minus 1j. You take it times 1j, and I have no idea what is 1j, and it's not documented. Nobody tells you here. So also, like, what is r? I can kind of see what phi is, but r, it's something else actually. So if I go back to the C++ code, I can show you then actually what this code then replaced with. And this code is now actually, as you see up here, it's just calling std polar. So this call to rect is actually polar, and I'm using a lambda to kind of play around with that to be able to plug different things in here, not call std polar directly, which actually I could do here. Then I don't need to have that anymore, as this turned out to be the correct way to do it. I tried a few other things, but this is how it works. So, and then we can delete. So it's practical. Yeah, so I use the pi from CMass here. This is kind of the size of how big the circle is. I have to play around how to kind of achieve different sizes and different things there. The start is for everything is red, and just different triangles are created here and then pushed back in the vector. This is not perfect yet, but just the startup code. Also, when I level up, I have code which is responsible for creating the next step and then displaying it with a paint event, which we see here. And one upcoming change is I have just seen that I need to create a paint function which is taking this painter by reference, because if I create an SVG with cute, which actually is my end target because I want to paint the actual end result onto an SVG to make it a t-shirt, this is going to happen in a different format, so I need to have an interface to paint on this SVG renderer later. And this is probably another episode of just C++ then. But today we're just focusing on the painting. This is the paint code in C++. Qt painter is anti-aliasing. This is responsible. Normally we have a different coordinate system on the Qt painter, but with this, the painter has the same coordinate system than the code which we kind of port from Python, which is using Cartagio coordinates, just normal coordinates with the 0, 0 in the middle. That's what is achieved here, and then this is the same. And then easily we go over all triangles. If they are red, we paint them, because this is the code when we paint the paths for the red triangles, and then we paint the paths for the blue triangles. Qt Painter path does not have like a clear or reset function, so I'm kind of resetting it that way. I'm thinking about if there are different and better ways, and I'm not sure about that currently, but anyways, these variables would be destroyed at the end of this function anyways, so that unfortunately in the critical path we have to live with that. And then we have to draw the outlines, which is simply this code. You probably ask yourself, what is add triangle to path? This is simply this small code here to put the triangle into the path. And if you see here, this path is CAB, and this is ABC. So this is differently, so I have to have this cannot call the other function. And also I'm closing the subpath here while I'm not doing this here. And then I call stroke path, and to paint the triangles I call fill path. And this is basically all the code which was needed, which got ported from Python. If I go back in the browser, I can show you that again. So this is a block entry. I'm going to link this below so you can look at the original, and there are some other solutions here, and it's actually quite fun to play around with. But while porting the code which divides here, I made the error here that it's b minus a and made it a minus it's actually b minus a, but I made it a minus b, and this caused a fairly interesting error, which I can show you if I go to my Twitter. And actually go to Twitter. So this is the Twitter of me C++. And these are the errors which came up. So fairly interesting errors to paint up. So if you make an error in painting code, it can get quite interesting. But if I go into the actual running program, I can show you how this works. Now with each level, we see that the tiling gets different, and currently it's still a little bit, I see that the rendering isn't perfect yet because there's where no, I have to probably also stroke a pass in the color of the triangle to make that fit 100%. That is because I set in the renderer anti-aliasing, and maybe I don't want to set anti-aliasing because actually the end result of this program will be, and now with more and more triangles, we see it gets more and more difficult to do that. So let's go back to the code. That's basically what I wanted to show you. This is a small cute program. I'm probably going to put a later version of this on GitHub after the t-shirt is out. The t-shirt is for the conference, which is in 1 month. So if you want a t-shirt, come to the conference. Maybe I'm also going to share the SVG. And I'm not sure, is there anything else to look at here in the code? Looking around if there's anything. I mentioned the thing with STD Polar. And oh yeah, one more thing. The J, which I previously mentioned, actually is in C++ 14 available as I. So you can replace it, like in Python, it is I or J, and in C++ now you can replace this with I. The CMAS rect function I didn't have to work with, and I didn't have to figure out what actually was it. I just have to call std polar, and I'm fine so fine. And with that, thank you. And with the next episode, I'm going to show you how to render this in SVG and Qt.